and I am generation Y. So I'm like, why should I do things? How can I make things better? And especially for the environment, and we still have a climate thing going on, I'm very happy or very eager to, at least when I program, I should program and deploy my apps in a way that I reduce my footprint. That's the least thing I can do. And I'm here with Martin Lippert from the Spring tooling team.
Yeah, hi. Welcome from my side as well. I'm Martin, work for the Spring engineering team. So the team that does the Spring Boot, Spring Framework, and all that stuff. And I work on the tooling extensions for IDE. So not really the topic of this session today. But since I'm very passionate about these kind of sustainability topics as well, that's why I try to combine both of my passions basically in this talk to tell you a little bit more about how you can reduce your footprint while doing your programming stuff as well, using Spring. Okay.
So let's first go into some standard things before we dive into the specific things we can make better, like using CRaC or native images. So first things first, right? One of them is please upgrade to the latest Spring Boot and Java versions. So please do so. If you need some data to convince your manager or yourself why you should do so, I ran a little bit of an experiment. So I took the Pet Clinic application from the Spring examples. I took an older version having Java 8, Spring Boot 2.7.3, and I put that with some load testers. So here you can see Azure load testing. It's just using JMeter, put them on VMs, and then run some load tests. You can see here my response time is not very great. Obviously, there should be some more improvements. For instance, if you deploy to a cloud, please make sure you have them in the same region deployed. Those are some other things. But I was like, hey, what if I just change nothing else? I use the same database. I keep this weird setup with different regions, because that's what I saw, what I'm also seeing at customers. And I just do this little update from 8 to 17. Just deploy it with using Java 17. No code changes, nothing more. And you can see here specifically, if you look at the homepage response time and also maybe so we have a database also attached here, a PostgreSQL database. You can see here, so just by updating to 17, I already get better response time for my homepage here from 21 seconds to less than 17, and also under load, right? It's a load test, so I put some traffic on it, and then here also the new pet creation also got reduced by 2 seconds, and that was kind of nice because I haven't done much, right? And that was really quick, so that's kind of one of the least things you can do. Obviously, we also said you should also update to newer Spring Boot versions. If you want to do that, or if you want to use 21, you have also to update your Spring Boot versions. And then I went a bit full speed and saw what can I update as well. So here I did hopefully most of the things you can do. So I updated to Java 21. I used the then new Spring Boot version 3.2.5. I did code optimization as well. So I also put the load testing and the database, everything in the same region to improve here again to get better response time. So make my app even faster, and then I can use less amounts or less instances of my app, which will then cause of having caused a better footprint. How can you do this? Thanks to Spring tooling, we have a few. So Spring Tools provide support for upgrading Spring Boot applications, and here's how it would look like. So you can, okay, that's not the full screenshot. But anyhow, so here's some refactor previews. So if you use the Spring tooling, for instance, in VS Code, and then you have your app. We don't have that, right? So, and then it gives you a list what you need to do, and then if you click on preview, that's what you would get. So you could even see here's the properties where you can see the change from Spring Boot to the new version, and on also setting the new Java files. So it's using Open Rewrite behind the scenes. I know we had some other topics about that in some other conference sessions. So I'm very, I would try it out if I were you, if you haven't already. So The next things, you can use like new things such as virtual threads, and also Spring MVC provides you support here. It's just a property file that you need to set in order to use that one. So I'm highly recommending using that as well. So you don't need like reactor at runtimes, and or classic ones wouldn't have a reactor at runtime or nonety. And then also like use the new things like Spring JDBC, got a lot of enhancement. I just used that in some of my latest demos. It's very fast to like deploy, and also like in terms of how to code it, it brings a bit more developer joy, I would say. But also the footprint is much smaller for the same workload. Since it's still in early days, the ecosystem needs to adapt still. And we also ran some tests. So like here, you can see request per seconds with virtual threads and without virtual threads for the Spring Pet Clinic application, which is using Spring Data JDBC and the caffeine cache. And we just searched for all the vets here in this test. And as you can see, like the more requests per second, the better. And obviously, if you give more more CPU and memory, you will have even better throughput. But yeah, so just so you know. And changing between virtual threads and without is just a change in the property. So it's very easy. You can also do that later on. Your code already exists. It's not much to change.
Yeah, so you see that the effect of using virtual threads is much higher if you have kind of smaller machines and smaller environments than you have really big, beefy machines. So you can imagine that the idea overall is, okay, let's try to jump on a smaller machine. Let's try to reduce the resource consumption by using virtual threads while achieving kind of the same request per second throughput here in the end. So that's kind of the overall idea that you can try to apply. What exact setting you need and how much you can reduce, it's really kind of up to your application, of course. But that's the overall thought here behind using virtual threads from the reducing footprint perspective.
Thanks. Okay, and then after we have set those standards, we have like two principles or two angles we could have a look at. So either we want to optimize for startup time, or we're going to go with optimizing for one-time footprints. So Martin, why don't you start with the startup time? Like we want to have like here stands milliseconds instead of seconds. So we want to scale to 0, and we want to run the app only when absolutely necessary, so we can like store something, snapshot maybe.
Yeah, so if you really look at kind of from the sustainability perspective on that, and you want to reduce your footprint, we are really looking at this from the perspective of trying to do the same as before, but with less resources. So we are not really trying to kind of optimize things to make everything faster, because faster is always awesome, or to make everything being able to answer more requests than before, because maybe you have more requests, whatever. The idea is really to do the same as before with less resources. And of course, you can approach this from these two angles, like using less memory and less footprint per instance that you're running is great. Right? So then you need to reserve less memory, smaller machines and things like that. And on the other side, you can try to say, I run stuff only when it's absolutely necessary. Right? So if you can shut things down, that's great, because then you don't really consume any resources. And there are studies out there that if you look at those studies, most of the systems in data centers are really not being used all the time. And they still consume high amounts of energy while just sitting around being idle all the time. And that's really a big resource drain and consumes a lot of energy, right? So forget about these ideas about if my software is running in the data center but is not being used, it doesn't consume any energy. That's not the case, right? It still consumes about 50% of the overall energy. So if you're running a data center and it's not being used, there's just the software being deployed and runs, but it's not being used, no one is accessing that, nothing, the data center still consumes 50% of the energy. And that's a huge amount of energy if you look at those things. So if you can switch things really off and not use them, that saves a lot of energy. And that's important. But if you want to do that, you have to have startup times that are really fast. Because if you want to kind of start up your applications basically when they are being used or on demand, if you want to go that far, you really need to have short startup times. You cannot think about seconds or multiple seconds or minutes or whatever. You really need to go down to the millisecond space. And that's why we look at those two things from these two different angles to really try to push the boundaries here, to do the same as before with less resources, either by not running things at all or by reducing the size that you really need to run those things. So if we look at startup time, there are different things you can do to basically improve that and go further. And the first thing is, think about the deployment layout that you use for your Spring Boot application. Most people actually, they use the standard thing that comes as a default with Spring Boot. It's kind of the fat jar thing, right? You drop the fat jar in your container, you run it, and that's it. And that's the least, or maybe not the least, but it's not the most efficient way to start up your Spring Boot application. If you change that layout, you can easily reduce your startup time significantly of your Spring Boot application. And this is, if you look at the documentation around that, there are different ways, for example, to have the exploded jar and even more sophisticated things that you can combine with class data sharing. We will talk about that in a second. So really look at that, right? If you want to reduce your startup time. We'll see some numbers a little bit later, but that's kind of a different or an important topic to really look at that, right? Don't maybe just go with the default. You can think about it and change your startup layout and your deployment layout slightly. You don't need to change any code for that, just the deployment layout. That's kind of an important first step to trim down the startup time. The second part is to use Spring AOT, something that's newly introduced for Spring Boot 3 to do more stuff at build time. So at build time, Spring AOT basically tries to find out as much as possible about your application, assuming this is kind of a closed world assumption, and knows about which beans are being created and how is everything being done at runtime, and produces code that avoids any reflection, any dynamic creations of things at startup time. So startup time gets a lot faster, right? Because there's just code highly optimized being executed, and that's it. It's really nice because it trims down a lot of these reflection magic that happens at startup time and finding everything on the class path and scanning and so on. All these things basically happen at build time instead of at runtime, so you can trim down your startup time even further, which is relatively easy to use if you use Spring Boot 3 because you can basically switch that on. It was originally built for compiling things into native images, a different topic. We will touch on that later, because for the native image, you need to have this closed world assumption and you need to basically know about those things up front. But the cool thing is you can use the Spring AOT thing for a regular JVM deployment as well. So it just creates additional code that executes faster at startup time, and you can use that just by running a regular JVM thing. So which is cool. The third option that you can put on top of all that, so it's all kind of, it's not either or, it's just you can do all those things at the same time. The third option is to use class data sharing. It is a technology by the JVM that is around for quite some time already. I think got introduced maybe with JDK 9 or so, maybe 9 or 10 or 6, maybe it goes back to 6. Oh wow. So it's a really relatively old technology, but this old thing is continuously being improved a lot, quite a lot by the JVM. It's just a regular JVM technology, which basically caches or snapshots. Maybe it's not the exact right word, but basically it puts information about the loaded classes and things like that in a snapshot file on disk, so that the next time you start the application, it basically grabs all those things and does not need to dynamically load the class and verify and all those things at runtime again. So that helps a lot by starting up the JVM for any application, right? Not just Spring Boot, but you can use that for Spring Boot as well. And there are a lot of optimizations going on at this space from the JVM team, which is great because if you have a Spring Boot app running, you automatically, more or less automatically, benefit from that. And if we look at some numbers around here, you can roughly see what this means, right, on the different things. So you can see that if I have the executable jar, this fed jar standard way, what are roughly this, just for comparison, the startup times that you can achieve here, and how you can trim that down by, say, I use the unpacked version, I use class data sharing, and then I use class data sharing and Spring AOT together. And you can see you can more or less cut those things into half, right? Which is already quite significant, I think. So that's great, and it's not a lot of work for you, right? You don't have to rewrite everything. You don't have to optimize everything yourself manually. You can basically just opt in to do things like this and to use things like this to get a faster startup for any application. Whether this brings you down to a number that enables other things, like on demand or things like that, I don't know. But if you save startup time, that's always always a good optimization, especially if it's that easy as here. And there are additional things that are going on in Spring Boot 3.3. So if you want to try that out, I think milestones or an RC release candidate is already out there for Spring Boot 3.3. There's another deployment layout available that's optimized for class data sharing. So that class data, it's easier for class data sharing to store this information and grab this information for all the basically the jar files on the class path and things like that, to really easily map that onto these snapshot files. So another step to make this even faster in Spring Boot 3.3 without you having to change anything except from these deployment layout, which you can then use. If you go to the documentation, the early documentation for Spring Boot 3.3, you can already see the documentation how to do that. It's quite just a few lines for how to basically unpack the application and how to run the application in that way. So that's awesome. And the next topic for that, if you go down one slide, is that that's basically, by the way, Sebastian also talking about this new deployment layout. So if you want to kind of get a reference for that, you can also search on the Twitter feed, on the X feed, or whatever that's called nowadays, for his tweet about that. In addition to that, the project Leiden on the JDK is trying to optimize these class data sharing even further. For example, by putting additional information that is computed at runtime into this snapshot files, into the snapshot information. For example, the stuff that the JIT compiler is doing at runtime. So it analyzes stuff, it creates profiling data, it optimizes things, produces optimized bytecode, optimized assembly code, and whatever. Put that information into the class data sharing as well, so that the next time you start it up, it basically has all this information already and can start from that kind of peak performance already without running through all these JIT compilation again and again, which costs time, costs energy, costs space, and you can just shave that off. If you really kind of want to go down that path, it's important to know that for these class data sharing, you need to have basically this archive or this snapshot file if you start up your app. So ideas are in place, and the early steps are being done for that. For example, if you build your app, it makes sense if you, for example, deploy that inside of a container to basically you build your app, you start up the app until a certain point, for example, put it under load or whatever, or until a certain point in time. Then you create the class archive, this shared class data sharing files, the snapshot files, and then you put that into the container to deploy this into production or wherever you want to deploy that. So that whenever you start up this container in this environment, you can start it up from already with these class data sharing information inside to get a faster startup. Which is, I think, quite nice, because that's a logical thing, right? If you're running inside of containers or Kubernetes or whatever, you can store your stuff on disk, yeah, that's fine, but that's gone the next time it's probably started, because Kubernetes throws the pod away and then creates a new one or whatever. So you cannot really, this data cannot really survive, or you would have to these kind of mounted device, mounted spaces, volumes, and put that in there and stuff like that. But you can really get rid of that if you put all that into the build pipeline and do that. And there are certain flags and automation for that in place. If you use build packs, for example, they will get this support for you. So, which is, I think, really, really cool. But there is kind of the next logical step is, if you see all these numbers, right? They are all kind of the easy things you can do, right? Relatively easy. Maybe the upgrade to the new JDK and Spring Boot version is not that easy, not in every case. But using the deployment layout, Spring AOT and things like that, relatively easy. You can trim down your startup time and your footprint quite a bit. Most of the time, you probably don't end up in an application that starts up within tens of milliseconds. Probably don't get down that far. If you want to get down that far, you need to look at different things. And that's what basically, where there are two other approaches, more radical, more drastical approaches, is to really trim down the startup time even further to the tens of milliseconds level. And if you go down that far, you can really do things like start up the app on demand, right? If a request comes in, you start up the app, you start up additional instances, whatever, only when it's needed, right? And one thing is what's called CRaC. That's kind of a project I think was invented by Azul, and goes back to kind of snapshotting processes on Linux systems. So the overall idea is that you basically start up your application, you run your application, you put it under load, all the stuff happens like JIT compilation and so ever, and then you basically snapshot the whole process. You snapshot the whole process to disk. And that's kind of supported by some Linux libraries, and that's with Project CRaC basically integrated into the JVM runtime, that you can do things like that. You can snapshot the whole process, and the next time you start it up, you basically start it up from the snapshot. And that is super fast, right? That goes down to just tens of milliseconds. So you can start this up with tens of milliseconds. In order to do that, you need to do these kind of start up the app, put it under load, create a snapshot, and then go on. And there's support in Spring for actually doing that. So that's relatively easy to do that. For example, again, in these build packs, in the build pipeline, that you can do this in the build pipeline. But it's not totally without any extra effort, because, for example, if you create a snapshot, you need to kind of close sockets, you need to close files, you need to close database connections, whatever. If you restore from a snapshot, you need to create those things again, which fits nicely within the Spring model of kind of starting and stopping the application context. So that's why Spring is nicely able to do this for you. But if you do things yourself, outside of the control of Spring, you need to think about that. So it's not super easy to do here. But if you do this, you can do something like run the app, create the snapshot, dump the snapshot to disk, put that into the container, start it up from this snapshotted version, which is, I think, really awesome. So it comes with a lot of benefits, right? Instant startup, it's really in tens of milliseconds. There's no warm-up at runtime, so there's no JIT that needs to be populated, no JIT compilation going on anymore. Everything is done, peak performance from after 10 milliseconds or whatever, and that's really awesome. And you can basically use that for any application, so that's great. Just requires a regular JVM. That's good, but it comes with a lot of downsizes. And first, you need to do these extra steps at build time, right? Start the app and produce this checkpoint, so that needs to be integrated. You need to open and close all these files and channels. If you do that yourself, we talked about that. And something that is probably kind of missing from most of the discussions is that the snapshot file that you create contains the whole process. It's a snapshot of the whole process. That means that if inside of the memory of the process are secrets, for example, the password for your database connection, that's somewhere in the memory of this process, it ends up being in the snapshot on disk. Right? So all the security details might be inside of the file on disk, inside of your container, because the container contains the snapshot inside of the snapshot. So someone who's really, really, really good at digging things out of those snapshots might be able to dig those things out of the snapshot. So implications, you probably maybe don't want that, right? So that's the difficulty. And it only runs on Linux. And you need to have specific permissions on Linux and so on. So it comes also with some downsides and so on. And it's not yet part of the OpenJDK. So it's not a regular JDK. You need a special build of the OpenJDK that has CRaC included. And whether the CRaC mechanism will make it into the official JDK, OpenJDK builds, you don't know. We don't know. So you need to go and hunt for these special builds from CRaC, which you can get, right? That's fine. But that's kind of part of the trade-offs. And there's another way to get down to the sub-millisecond startup time, or maybe not sub-milliseconds, but tens of millisecond startup time, with this, which is about kind of GraalVM native images. Probably you heard about that a lot already in the keynotes or whatever, but we will touch on that as well, just briefly with Sandra.
Yeah, so if I scale to 0 with Spring Boot and GraalVM native images, I can get a kind of the same thing. So here's like, I start my app. So here I build it and then I run it. And here you can see it will also be like pretty fast. So I have the AOT transformations and then it will run like in milliseconds. Okay, and we will discuss the native images also later, since, where am I? Yeah, okay. Since it also goes well with the next topic, which is like, let's reduce also the runtime footprint. So we're gonna optimize for startup time. I already showed very briefly that we can have that with GraalVM as well, but to have like, to also reduce the runtime footprint, I feel that native images is a great place to start, or potentially the best one. So here's like the footprint under load. So you have like the traditional JVM matrix for the Spring Pet Clinic app, which is using JDBC. I also have the database connection. We're using Spring 3 something here, so one of the new versions. And here you can already see that in terms of how much memory my app needs to perform the same thing, it's a lot less. Here we're using the GraalVM Community Edition. As you have seen in the keynote, there's also the Oracle GraalVM version, which brings potentially a bit more even. So, but that's like coming with a license cost, so that's something you can discuss with the Oracle folks. So with GraalVM native images, I have my instance startup, so I have like the milliseconds instead of seconds for the regular JVM. I get a much smaller footprint, so it's very tiny container images are possible with my native images. I have like no warm-up time, so my peak performance is available like immediately, so I can just start and go. And yep, and some trade-offs. So I don't have like dynamic capabilities at runtime, so like we know that the JVM will do things for us, like optimize potentially for performance. That's something we don't have, since we don't have the JVM any longer. Sometimes it's a bit hard to start, especially if you use like the newest Java versions. Like I'm always like very eager to use like Java 22 nowadays, and then I needed to add some metadata, and I needed to like exclude some libs there. So we still put long build times, but they did a lot to improve that one. So I was almost for taking that off the slide. If you want to debug it, you have to go like low level again. So you go back to the kernel level, like the GDB level. And we don't have like Java agent support. You can discuss it with Fabio when it will come and how it will come. But when I want to monitor native images, and I'm also like a Docker and Kubernetes person here, I would just use like native tools for that. So I'm a huge fan of OpenTelemetry for those monitoring. So I also gave like other sessions at DevOps France. So we are able to now collect, especially from Spring apps, I would say all the relevant data and then monitor it correctly.
And I heard rumors from Fabio about the low-level debugging that might improve in the future. So it's not a rumor. Oh, you can share some official stuff. It will happen. So kind of real source level debugging for a natively compiled Java application, which is awesome. I think I'm really looking forward to that.
Okay, and with that, we still have time for questions and then jump to the conclusion.
Yeah, I have to apologize. I did not mean sub-millisecond. That was just an error. Tens of milliseconds. That was what I meant. Someone corrected me and said there's about a 3 orders of magnitude difference between sub-millisecond and tens of seconds. That is absolutely correct.
Yes.
And it was just didn't mean sub-millisecond. I mean sub-seconds or tens of milliseconds in this case.
So thanks for listening carefully. Just for everyone, the hint was there's about a 3 orders of magnitude difference between sub-milliseconds and tens of milliseconds. Yeah. Thanks for listening.
Makes absolute sense.
So what about that question? How would I measure the difference in resource consumption between the idle application versus starting and stopping the application?
So if I understand the question correctly, it is about, does it make sense to kind of start up and stop the application versus keeping the application running idle in between? Is that correct? I'm not sure who asked the question, but if I understood that correctly. Mm-hmm. Maybe?
So
who asked the question?
Oh, I see. So now I want to measure if I keep my app idling around and then I use it whenever I need it. Okay. And then I measure my energy cost, put that on a chart, and then I have the app which would go down and up again, scale to 0, free all the resources, and then it would be there again. You mean that? So I read between the lines that the person says that if I start an app, it will need more energy than if it would be already there and then get the traffic and do what it is supposed to.
Yeah, I think it, so from my poor perspective, if you really have kind of these applications that are kind of having all these requests, kind of thousands of requests per second or whatever, it does not really make sense to start and stop it all the time, right? But if you think about it, and I'm not sure who has CI systems running, build pipelines running. Mm-hmm. Yeah. So, do you really shut them down overnight when no one is using them, or when there's no commit and things like that? Some folks shutting them down. That's awesome.
But I think if you use GitHub and GitHub Honest, they're always shut off, right?
They're always shut down. So that's good. That. Keeping them running, not that awesome of an idea. If you have an application that is maybe not being used thousands of times per second, but maybe just every minute, certain hours, whatever, it's probably a good idea to basically shut them down and start them up again, if you can do that. Or if you have these kind of, you really want to have high availability systems, you have kind of multiple instances running, just in case one instance fails. It is an option to say, I don't have that because it starts up so quickly that I can basically not do these highly availability having duplicates running just in case, right?
But thanks for the question. To my knowledge, tools like Azure Monitoring, we don't support that yet. So that's a good hint. I can give that to our product team.
Yeah, and from the stuff that I learned about the sustainability perspective, and I looked at that for many years now, is that usually there's no one single solution to the problem. There can be very, very difficult situations, very different situations from one occasion to the other, like what is the data center, and where do I run things, and when do I run things, and do I run things distributed across data centers or not? Does the latency matter for my application or not? When is the application being used, and things like that. So there are many variables inside, and there's no single solution or single answer to really find the optimal way to run this app from the footprint perspective. But I think, and what I would like to kind of motivate everybody to is to think about that from this perspective, right? Not just think about things like, yeah, maybe I have slightly larger instance that I really need just in case. So there's some buffer for memory and some buffer for CPU, or maybe I need a bigger box, so just to be safe. Or, oh, maybe I need 3 replicas instead of 2 just to be safe, or whatever. Think about stuff from also the perspective of the footprint, right? Can you do the same things with less? Can you do the same thing with fewer instances, with smaller instances, with small applications, can you adopt those things? Can you move that to a different data center? Things like that, right? Many different options, and there's no one single solution, but I would like to start to think about those settings from this perspective. And that's basically my main point here. And then giving people different technologies at hand and think about different things. And I probably only know about 1% of all the different options that are around to achieve that goal. But to start to think about that and move into this direction of trying to run your stuff with less resources and with fewer resources and not that often, not all the time and things like that. It really makes a difference.
So does Spring Boot take care of changing environment variables for restoring CRaC snapshots to different environments?
I don't think so. So you have to basically run the snapshot in CRaC in the same environment that you run the stuff later on, as far as I know.
Okay. Isn't the main benefit of class data sharing, memory sharing between JVM instances?
I don't know. The thing that I remember is that in the IBM J9, or the, what's that called nowadays? The Adoptium J9 thing, whatever. In the J9 implementation of the JVM, there was something like sharing class data across multiple instances of the JVM running on the machine and doing things like that. I think in the OpenJDK that's not the case, but I might be wrong. I don't know exactly. But it's not the main purpose for the project laden and ongoing things, as far as I know. It's really about caching things that happen at runtime, making it really efficient to create smaller startup times, to really speed up startup times for that. And if you don't need JIT compilation at runtime, you can probably also save some memory. That's kind of a nice side effect, but the main driver is I think from my perspective, is to get the startup time really down to something that's super fast.
Okay, I also like this question. If some improvements can be done via config, why aren't these settings default? Yeah, especially for Spring, where I usually think that all the defaults are like best practice, most sustainable, most fast.
Yeah, that's an absolute valid question. And the team is asking this question to itself and probably will change defaults. Changing defaults, of course, also always means that everybody will be affected who is using defaults. So if you jump to the next version and all the defaults change, many folks will be affected basically under the covers, more or less automatically. So you really need to think deeply about which default setting to change. So it's not super easy, but the overall idea makes super sense, yeah, for us as well.
But then I guess not all Spring apps are the same. So maybe we have to configure a bit differently. So.
Can we get the slides? Yes, of course. I have no idea where, but
we will treat it.
Yes.
At least.
You will get the slides.
Okay, did we miss an important one?
Any more questions? Also, if there are any more questions in the room here, right? Without using Slido. So it's okay to ask questions in the old way, right? The old style, the non-electronic, non-anonymous way. That's okay.
Also, if you want to add something we have missed, but everyone should know to be like better and more sustainable in their development and deployment. Okay.
And I have 20 minutes left before I go to lunch. If you want to chat about more sustainability things, I'm super happy to do that.
Okay, we are not
Thank you for coming.